Yeah, yeah. Don't worry, it's a friendly crowd. Yes. Okay. So you're all warmed up. Well, you know, right. The whole idea is if you can find a community of people who want kind of shared interests, right? And there's folks working. Oh, okay. Welcome to the club. Okay. Well, you know, there's a little bit of a vetting process of like, you know, how are you different, and are you reinventing the wheel? It's just, you know, all right. What institution are you from? I can't remember. Oh, Lancaster. Okay. I haven't, but I feel like there may be, or have been, I suppose, somebody else involved in the IETF from Lancaster. Dan King? That's not somebody I know. In routing? Is he in routing? Routing? Oh, PCO, okay. That's not, I'm kind of a transport guy, so that's why I wouldn't know. Yes. Well, it's not, that is in fact transport to some people, but that's not, you know, when I say transport, I'm talking about TCP, UDP, ESXi, Quick, yeah, exactly. We call the transport area in the IETF. Yes. Well, I mean, you know, they're just labels. Is this your first IETF meeting? Did they have like an orientation? Did you get a chance to go to that? All right. Well, so, you know, the internet only just barely works. Well, there's a good document called the DAO of the IETF. Okay. Yeah. There's a bunch of keywords, you know, in the community, and it unpacks some of those, so at least you understand, you know, what people are referring to when they use. It's the shared language, right? Right. Yeah, but the process here is different in some fundamental ways from the IETF, and you'll probably pick it up pretty quick. Yeah, and it's, you know, it is an organization that's got sort of research as its DNA, and so there's a sort of a lack of structure that is a good fit for research, but can sometimes make things like producing documents go kind of slowly. Yeah. Yeah. So I think basically, so the goal of this session is to help identify people who have something that they want to work on, to help identify collaborators. And yeah. And so, you know, if you're bringing, you know, your technical insights, one thing that collaborators can help you with is guide you through the process, you know, how to be effective. Good. I'm sorry? I can't. Oh, let me get my computer here, and I'll tell you. I think the whole session's going to run probably about an hour and 15 minutes. Let me just see where you are. No. Oh, there we go. Okay, you are 12 out of 17. So you're probably about 45 minutes in, I'm guessing. Maybe half an hour. Oh, well, you probably got time to go out and grab some food and come back in. No. Don't worry about it. Okay. Nice meeting you, Nick.
Okay, folks, let's get started. It's about 5 after. We've got 17 talks tonight, and it's probably going to take us, I think, probably a little bit over an hour to get through them. Usually things move pretty quickly. Would somebody mind closing the door at the back of the room? Thank you, Ole. So, my name's Aaron Falk. This is the HOTRFC Lightning Talk session. If this is the first one of these that you've been to, let me just explain very briefly what it is. The idea here is to give a forum for folks who've got something that they want to work on, an opportunity to find collaborators, and to do it in a way that makes, that's sort of an efficient use of time, lets us get through a lot of ideas. So we see things that are advertisements for BOFs, which are new work coming into the IETF, or folks who've just got an idea, might not be at the BOF stage, or have a particular paper or a topic or a research area that they're looking for people who share that interest. So I think you're going to see a wide range of stuff tonight. We try to do this at every IETF, and so if you're inspired next time, feel free to shoot an email. The link here has a little bit of context for the session and contact email address for me, and so feel free to reach out. So I think that I've probably spoken long enough, and so Tommy's going to be our first speaker. Let's bring on Tommy. Oh, sorry, one format thing. So the talks are restricted to last no more than 4 minutes. When the speaker starts, I start a little timer. When the timer quacks, we're using the Lars-Egert time management rules, which is that when you hear the timer quack, I would like everybody in the room to clap. So I'm going to count on you for help. This is how we stay on schedule. Great. Get warmed up. Very good. Okay, please welcome Tommy Pauly, our first speaker. Tommy, you got the clicker?
Yep.
All right, let's see.
Let me see if it works.
Oops.
It works.
All right, you're on.
All right. Hello, everyone. I'm Tommy from Apple, and we're going to talk about DNS privacy. It's maybe a controversial topic, but I think it's one that's very interesting. So this is what DNS traditionally looks like. You have a resolution that you often do to your local resolver. You connect to the name that you get from that. Some people are concerned that the local resolver may be seeing things and be able to profile you in ways that you don't want if you don't trust it. So one approach to solve this is say, oh, we trust some other resolver in the cloud a lot more, so let's do that. People have concerns about this too, because how do we know we trust that? And that also can see everything you do. And it's another point that can also be monitoring you. So we have a proposal that we're calling adaptive DNS privacy to try to have more different resolvers in the mix. We want to be able to discover many decentralized DO servers. We want to be able to designate DO servers for given domains so that you can say what you should be using for a certain set of names. We also want to discover what the local policy is so that we can do the right things on the local network and then have a good algorithm for how to use all of our DNS queries. So you can get something that looks like this. Lots of possible options that can coexist and hopefully make sense together that give us privacy without tying us to one option. There is, of course, an interesting question of how do you bootstrap this system, especially if you don't want to just use the local resolver without just trusting someone else instead. For this, we have a second document, which you may be interested in. It's called Oblivious DO. It takes inspiration from the work on Oblivious DNS. It allows you to proxy DO queries in order to mask your client IP address so that no one DNS server knows both your IP address and your query content. The picture kind of looks like this. You have one more hop in here, but it gives you really good privacy properties. So that creates a whole ecosystem around this that we can hopefully improve DNS privacy for everyone and have it be very scalable and something that even the local networks can participate in. So if you want to learn more about this or get involved, we're going to be talking at the ABCD BOF. We're also going to be presenting this work in more detail about how the protocol works at dprive. We have 2 documents here, And we also have a GitHub where we really welcome any issues or pull requests that you want to have, get a discussion going. We want to solve this issue for operating systems in general, and anything we can do to make this situation better, we are open to. So please participate. Thank you.
Thank you, Tommy. So let me just point out that all the slides and contact information are posted on the meeting material site. So if you want to download anything for the contact to show up at this stuff, feel free. All right. So Shaiwen Yu.
Good afternoon, everyone. My name is Zhiwen Liu. I'm from Tsinghua University. I'm very glad to be here to share our work with you. Our work is deadline-aware transport protocol. As we all know, the internet is becoming real-time. More and more applications has deadline requirements for their data transmission, such as video conferencing and cloud VR gaming. The deadline of this application can be divided into two categories. The first one is if the application is push-based, then the deadline means the one-way time. And if the application is pull-based, then the deadline means the RTT. And those applications are transferring data in block fashion, like the frame in the video conferencing. The block is the minimal processing unit of application, and the deadline is also means the block completion time. These applications are usually generating and transferring multiple blocks concurrently. So different blocks are of different importance to the user experience. Like in some scenario of video conferencing, the audio data may be more important than the video data. However, existing transport protocols lack support for these transmission requirements. Even though some researchers has proposed the deadline concept in various protocols like HTTP and some modified TCP, but they have their problems. The first one is that they are hard to deploy. Second, they have no optimization for the deadline transmission. They maybe just drop some stale data. And the third one is that they lack support for pull-based transmission. As a result, applications are forced to do their own customized solutions, like Shopify for video conferencing. These solutions are all in cross-layer fashions, and these efforts are very complex and redundant. So we need a transport protocol to provide a deliver before deadline service. Our solution, DTP, is built on top of Quick and is very easy to deploy. We build DTP both in transport layer and HTTP layer. And DTP provides block-based data transmission instead of quick stream. Application can mark their data with priority and deadline parameters. You can see in the figure is our architecture. The DTP will schedule block transmission order based on the deadline, priority, and network condition. And it will also drop some low priority or stale blocks if necessary. We also apply redundancy for some tail packets of a block to avoid the retransmission delay. The congestion control is responsible for controlling the RTT below the deadline. And we can talk about the implementation of DTP later, maybe after this hot RFC if you are interested. And you can also refer to our draft. Here is some part of our evaluation results. We can talk about it later if you are interested. And we are looking for some collaborators to develop application based on DTP and do some further job. If you are interested, please catch me during this week or email me at this address, and you can learn more about our work from this page.
Okay, you can stop clapping now. Okay, thank you. Our next speaker is Stephen McQuiston.
Stephen McQuiston is our next speaker.
Okay, so hi everyone. I am Stephen from the University of Glasgow, and together with Mark, who's somewhere in the audience, we've got a couple of drafts that are looking at formal languages and how they're used in the IETF. So broadly, what we want to try and do is to use formal and structured languages to improve the quality of the standards that are produced at the IETF. So we want to either generate documents that are written using formal and structured languages, or we want to try and extract structured elements from within the documents themselves. And once we've done that, we can then use tooling that can maybe generate parser code for the protocol that's being specified, or prove properties about the protocol, or perhaps just generate the examples that are within the document from the document itself so that they're consistent within the same document. Now, the particular draft that I'm working on is trying to describe a machine-readable format for specifying the syntax of protocol data units. And for the most part, that looks very much the same as the way we're specifying the format for binary protocols at the moment. So we've got a packet header diagram followed by a sort of description list of each field that's in that packet header diagram. And essentially what the draft is trying to do is to bring some consistency to this. So if we all use the same format, then we can develop some tooling that can extract these diagrams from the draft, and then we can start to do some interesting things with that. So first of all, we can do some sort of simple checks, simple but effective checks. So we can check that the diagram matches the description list. Quite often it doesn't. And perhaps more interestingly, though, we can maybe generate some parser code from the definition of the protocol itself. Now, the draft that Mark is working on is quite different. So he's proposing that you write your internet drafts using ASCII-Doc, which is a markdown variant. In the same file as that, as your internet draft, you then add a formal description of the protocol written in Idris, so with dependent and linear types. As I say, this is Mark's draft, so if you have questions about that, you should ask him. But what that then gives you then is the ability to generate an XML RFC v3 file that has examples that are correct by construction. You have definitions in formal languages like A, B, and F that have been verified. And you get a formal proof of the application of Postel's law, and much more. Now, we're aware that there's a lot of other languages, other formal languages that get used in the IETF, things like Yang or ABNF or CDDL. And so beyond these sort of narrower projects and drafts that we've got, we want to try and bring about a broader discussion about the use of formal languages in the IETF. To do that, we're going to have an informal side meeting. We're going to have that on Thursday night at 8 o'clock at the winery at Chimes. That's just across the road from the venue. You go downstairs into the courtyard. If you're planning to come along, then send us an email and we'll make sure we don't miss anyone. If you're interested in the work but you can't come along, again, send us an email, bump into us in the hallway. We'd love to discuss it. Thank you.
Thank you, Stephen. Come on up. Next speaker is Philip Helen Baker. Can folks in the back hear okay? Raise your hand if you're having trouble hearing. The speaker, not me. I'm getting real close. Okay, so people are fine. All right.
Hello, I'm Phil Helen Baker, and I'm here to talk about the mathematical mesh BOF tomorrow, Monday morning, first thing after breakfast. So the objective of the mesh is to make computers easier to use by making them more secure. So use security to make the process easier for the user for a change. And the basis for this is that, first of all, we're going to cryptographically connect together every device that Alice owns so that her phone, her tablet, her laptop, etc., and all her IoT devices all have a public-private key pair on them. And we've got messages that can flow between them to manage all that. And so whenever we want to set up a communication between those devices or with another party, we've got the public and private key there as the basis for you to be able to do that. So there are three core problems that we address in the mesh: provision the private keys to the device, provide the means to obtain the corresponding public key, and to secure data at rest. So So security today, what we have to do is we've got a whole bunch of different applications. We've got SSH, PGP, and all that stuff. And they're all silos. They're all a law unto themselves. And security tends to fall down between the cracks, between our applications. We need to be able to join all those applications together into one security infrastructure. And the mesh is a proposal for that infrastructure. So what we have here is a picture of the mesh in the large. And as you can see, there are a lot of moving parts there. This is a platform, and it's architected as such, because, you know, I'm a systems guy. So the mesh itself is that green box in the middle, and that rests on 3 core technologies. UDF, which is a naming technology, PGP fingerprints on steroids, DARE, which is a cryptographic message syntax, blockchain in JSON with encryption, and metacryptography, which is a way of going beyond the crypto in PGP and Bruce Schneier's Blue Book. You know, most of us have been using the same crypto for 25 years. They developed a whole load of stuff in the 90s that we don't use here. I want to start using some of that. And I'll be talking about how we can do that in the BOF. So there's a lot of stuff here and a lot of applications that could be built on top of it, on top of the mesh. For the purposes of the BOF and starting a working group, we're proposing to focus on just one. And the one that I'm proposing that we start off with is providing a end-to-end secure way of managing passwords. So we provide an end-to-end secure password vault on every machine that the user has, that is there ubiquitously, so they can start using long and strong passwords because they're going to be available on everything that they're going to use. So we can get away from this problem. And, you know, you've all seen this. The problem here is that the shortest password that is secure is far longer than any user could ever be expected to learn. And you cannot get around that with any algorithm hack or whatever. And I can go through the math of why that's not possible. We've got to get away from passwords, and the mesh provides a way to do that.
Okay, thank you, Philip. Our next speaker is Savio Moray. Did I get that right? Sorry, I tried.
So, hello, I'm Savio from the Federal University of Rio de Janeiro, from the LabNet, and I'm going to present...
Clicker right behind you. It's a clicker right behind you. On the floor. Do you see on the... Nope. Look where I'm pointing.
Sorry. Okay. I'm a little nervous, so okay.
No worries.
So I'm going to present my proposal of extension to the MUD-RFC. So the problem is that the MUD-RFC is not efficient against new vulnerabilities. This is not exactly a problem because of MUD, because they are. This is not the proposal. But a new vulnerability can use a whitelisted traffic by the MUD, and this needs a firmware or a MUD update by the manufacturer. And the problem of the point of view of security is that we have only one point of failure, that is the manufacturer. So this can take a long time to be done by the manufacturer. They may exist no more, or can just decide do not fix the bug or solve the problem. So the good part of the history is that the Security Operations Center every time discover and disclose information about botnets and other vulnerabilities, and we can use this information, the behavior of the botnet or vulnerability, to protect ourselves. And another important stakeholder in this part is the ISPs that has their bandwidth being used by the DOS traffic and other unwanted traffic. And in the other part of the stakeholders, the end user want to protect their security and privacy. So the proposed extension is to use well-known data about vulnerabilities. In this case, we are talking about botnets, and the data about botnet is being collected by honeypots. The SOC collect the data and process and make a file just like the MUD file, but describing the botnet network communication, doing the botnet network description, and making it available by a server HTTPS, just like the MUD server. And the end user can use this data, can configure his home gateway to consume this data. And the home gateway will match the botnet traffic and the IoT devices traffic to address the vulnerabilities to the devices that are exposed. And in the critical case, do blocks, or ask to the end users, the administrator of the network, ask for a block or not, or only alert. So in the end, the blocks are done and the vulnerabilities are blocked. So thank you very much for the attention. If you have any question or interest on the discussion, this is my emails, and I'm here by all the week.
Thank you, Savio. Okay, our next speaker is Richard Lee.
Thank you. I'm Richard Lee, and thanks to Helen for organizing this event. It's quite useful. And so people are always smart about the past, but sometimes they are also smart about now. It's very dangerous to say something about the future, especially for something as dynamic as internet and as hugely scaled as internet. But fortunately or unfortunately, I'm now on the dangerous zone now, today, at least. So before I talk about the future, let's take a brief look at the current internet. So internet has been very, very successful, but its core part is based on a few principles, concepts, and technologies. Fundamentally, it's based on something called statistically multiplexing. So the major purpose is to maximally utilize the link. On the protocol stack part, it's evolving day to day. That's more or less capture the kernels like a protocol stack, except the MPLS is missing, should be inserted somewhere. And internet is huge, but it's built by switches and routers. From these switches and routers, you can only expect no more than three types of capabilities. One, best effort. That's the most popular and mostly used and default. Second, diff serve, especially support some like voice video applications. You can expect no more than 8 classes of services. Another one is traffic engineering. In turn, it's based on traffic stealing or explicit paths. And in the meantime, it can also provide some guarantee on bandwidth, but not throughput. And sometimes if your network is broken, it can provide some fast reroute. But if we look at the history of all the internet protocols, you'll see that the mostly used protocols are pretty old. It's already more than one generation. For example, like IPv4 is still like used today, mostly used today. It's already 38 years. Even for IPv6 is already 24 years. So it's already one generation if you have a baby, and now it's already probably graduated from university. So many people, especially from academia, they are thinking, can we do something inside the network? So that's about the current IP. So as I said earlier, it's very predictable, about something in the future. Here and in ITUT, there is a focus group on network 2030. They have worked for for 1 year or so. They have identified something. And this triad, to summarize it, the first one is that very large volume and tiny instant communications. For example, holographic type of communications. You may or may not know that. Right now, we are starting to deploy 5G. One application is AR/VR. AR/VR is next to video communication. But what will be after AR/VR? So people tend to agree the holographic type of communications will happen sooner or later. And for example, we could support something called holographic teleport. So that will require really short latency. And after the meeting, please ask me why the latency should be as low as like 7 milliseconds. And also very large volume, it will be a few hundred. All right. Thank you very much.
Okay, thank you, Richard. Our next speaker is Liang Geng.
Good evening, everyone. I'm Liang from China Mobile, and I'm going to talk about computing first networking today. So I'll start with some background. So edge computing, very, very popular word nowadays, and emerged by the introduction of 5G core network, which actually intrinsically support this. And I'll start with some facts in China Mobile. So we have more than 600 nodes of CDN, and those nodes can be upgraded to virtualized CDN, which have a common infrastructure layer, and then it actually can naturally upgrade it to edge computing nodes. So we're talking about from the city level to county level and even to the on-site level of the infrastructure layer, we are going to see more than maybe tens of thousands or maybe hundreds of thousands nodes that used to be only router-based infrastructure, but nowadays it's going to be integrated router and then back-to-back with some IT infrastructure installed. So the network originally are designed to optimize connectivities, and we treat cloud, the data centers are users of the network, users of our connectivities. But nowadays, if we have the distributed manner of edge computing deployed, we're actually talking about changing the role of edge computing or cloud computing to be from the user of the network becoming a part of the network. So seeing the characteristic of edge computing, it's actually very limited in terms of resource, and it requires heterogeneous resource distributed, because not all the edge computing nodes can have GPU or other ASICs capabilities, but some of applications really require that. And we have other requirements, like we need to dynamically distribute the traffic to overcome the outcome of the limited resource caused by the edge computing node. So the question raised here is, how does the network help applications to find the optimized edge computing node? And how does network help edge computing nodes to offload the traffic? So that's what CFN is designed for. So it actually designed to be able to distribute computing resource status across the network. So we can use that status to do hybrid routing, hybrid algorithm, considering the computing status and the network status together. So it helps edge computing to provide local insensitive equivalence services and dynamic traffic computing offloading, and also seamless switchover between edge nodes with flow affinity. So we're going to talk about this more in this meeting, and we have a side meeting hosted in the morning on Thursday in room VIP A, starting from 8:30. So you're welcome to join us and have a discussion. And there are 3 drafts actually uploaded on the website, and if you're interested, you can have a look. And if you have any further information that you need further information, please do not be hesitant to contact me. Thank you very much.
Thank you. Okay, our next speaker is Yijali.
Hello, this is Yizhou. I'm going to talk about single slide only. So this is about loops, local optimizations on path segments. The goal of loops is to provide a local in-network recovery over some specific segments to optimize the packet delivery. A very typical usage scenario is over the when there might be multiple overlay segments. And for certain segments, there are higher loss compared to the others, and this contributes to the overall loss most. In that case, we possibly can provide the so-called local in-network recovery by either retransmission or FEC. So we had above in last IETF meeting, there was quite a strong interest showing that the standardization of the work was required. So we are going to meet in this meeting to discuss more detailed design issues. We'll include the encapsulations and the detailed retransmission operations, possibly sketch FEC version, then clearly outline the work to be done in loops. So who might be interested? Of course, the transport protocol designers, and this time, because we are going to touch a little bit more on the encapsulation, so tunnel protocol designers, and also the FEC experts, you are all welcome to join us. And the time will be on Tuesday morning in the room Orchard. There are 3 drafts available, so you can have a review if you are interested. So thank you.
Thank you, Yizha. Next speaking, Sophia Selly. Shelly?
Yes, Sally.
Selly.
Okay, hello. My name is Sophia Selly, and I'm going to present you about the version 4 of the off-the-record messaging protocol. For this,
Not working?
okay. So for this first, one of the questions that we was actually wanting to talk about is what the off-the-record messaging protocol is. And what is this basically is a protocol that provides end-to-end encryption for users who are having a conversation between 2 participants. And it was created in 2004 by Nikita Borisov, Ian Goffin, and Eric Brewer. And what it aims is to give 3 important properties, which was forward security, authentication, and most importantly, deniability. In the sense that what I said, that it wanted to provide end-to-end encryption and also to provide security in the case that one of the long-term keys was compromised. It wanted to provide the security that if it was compromised, then messages that were exchanged in the past were actually not compromised if one of the keys was compromised. And it also wanted to provide the property of deniability in the sense that there was no way to create proof of authorship if someone managed to compromise the conversation. But of course, OTR, as I said, was created in 2004. And since then, a lot of cryptographic things have happened. A lot of cryptographic properties and definitions have changed. So that is why we're creating the version 4 of this cryptographic protocol. As I said, we are doing the version 4 of this protocol because we wanted to update some of the cryptographic primitives that were previously done in the previous versions of OTR. And what we wanted to do is to obtain the different properties, the definition of deniability that the protocol had. In the sense that we wanted to update the definition of deniability, as right now there's different versions in the academic part of cryptographic of how to define deniability. And we wanted to also update the different cryptographic primitives that were used. And we also wanted to update the protocol to new network models in which people were actually wanting to have online and offline way of communicating. So we wanted to obtain of that. So basically what OTR, how it looks like is that basically you have a 2-participant communication, as I said, in which Alice and Bob want to talk to each other. They would request to have an OTR conversation. That is started a process in which they authenticate each other in a deniable way by exchanging the long-term keys and also by generating a shared secret. And by then they started actually to exchange the messaging with each other by using the double ratchet and using encryption keys that will be used per message only, so no keys will actually be compromised. So basically, right now, what's the state of OTI in its version 4 is that we finished the specification in the sense that we finished the cryptographic specification. We are still doing an implementation on C and in Golang, and some people are actually also doing this implementation at Java and Golang, and some people are interested in actually doing an implementation on C#. What we want to do and what I'm presenting right now is that it will be really interesting to have an RFC. There has been some interest in the past to do an RFC for previous version of OTIA v3, but we think that it's very important to actually do a version 4 of the RFC of OTIA, because this is something that current secure messaging applications are actually based upon, like the Signal protocol. So actually having a specification of the OTIA version 4 in its current form would be actually something very interesting for the secure messaging world. If you want to learn more, please check out our repos that you can see here. And thank you very much. You can reach me on my Twitter account or the Twitter account of OTIA. Thank you.
Thank you, Sophia. Okay, next speaker is Bob Moskowitz. And Steve Card. Well, Bob brings his own staff. Excellent.
You want to click it? Hi, I'm Stu. He's Bob. So I'm going to motivate. He's going to talk about the work in the host identity protocol to try to get the job done. So fundamental problem is gap between physical space and logical space. I see an unmanned aircraft there. I don't know who it is. I don't have any way to contact the operator. If some emergency situation arises and I need to contact the operator, how can I do that? So in the United States, the Federal Aviation Administration is expected to propose a rule next month. Other civil aviation authorities in other countries are doing the same. There was some work done in ASTM International. Just last week we were there. They released their first version of the standard. It's good as far as it goes, but it does not make the information immediately actionable. It doesn't make it trustworthy. It doesn't allow me to do a one-button press and get in contact with the operator. And so we're looking at taking various IETF standardized protocols, leveraging them to address this application. And I'll leave the details to Bob.
What's needed here in an extremely constrained environment? Bluetooth 4 is a basic minimum. Bluetooth 4 broadcast messages is the minimum basis for the communication. Extremely constrained message format, extremely constrained content. What can we do? We need to provide trustworthy identity to pair with physical location data. It turns out that the host identity tags, which are valid IPv6 addresses, can be used over this broadcast media Bluetooth to provide provable ownership by using the host identity for the signatures. Give us full mobility and multi-home support when we need to communicate directly to the operator. However, we find where that operator is, to tell them, please abort your mission now. Timing on this can be very, very critical, as drones, these things can move quickly in the airspace, or they may be hovering. So secure registration protocol is also needed to be able to register the devices on a first come, first own the ID, so that you say, I have this ID for this device. It may be long-lived. The hobbyist has an ID, long-lived. A delivery company may have the ID for every single delivery mission, so that the people cannot observe to say, oh, this is a UPS craft, this is a Amazon craft, so forth. So we expect both sorts of environments. What we're doing right now, we have the US use case draft, which is out, that Stu authored. And for myself, I've authored the hierarchical hits draft, as well as extension for the registration protocol, as well as getting together the new crypto we're going to need for this lightweight environment, new in terms of what we've used, but it's NIST-approved crypto, stuff which has been out for a little while. Using EDDSA, KMAC, C-Shake, KAC, well, that's waiting for the light crypto competition to finish. We're looking at actually signing messages, these broadcast messages, because there's no state. These are messages coming out on a broadcast. We had a hackathon yesterday and today. We made some progress. Adam's doing some great work of coding, and expect to see him in the code lounge to continue working during the week while he can. We need to progress these drafts. A lot more testing, both here and coming up. Stu and Adam are located at the Griffiths Air Force Base, or the old Griffiths Base, the UAS test site for the FAA. We'll be doing testing there. We need to liaison with ASTM to get what we're doing into we're expecting a rev of their document because of the FAA rulemaking. we're hoping. We need to look at how we can get very, very tight objects working on these very constrained environments using CBOR and the rest. Bob Tuesday.
Thank you, Bob. Okay, our next speaker is Paul Congdon. Yes, but the microphone is is down there. So
down here.
But you
Okay.
can stand up here if you want. I mean,
No,
go
I'm
wherever you
fine
want.
down here.
Yeah.
Okay. Hi, I'm Paul Congdon. I've been talking about data center congestion control the last couple of IETFs, and I'm trying to find where's the best place where we can get more interest, more people, more review of our drafts and development of them. I showed this picture last time, but I liked it so much I wanted to show it again. Data center congestion is different, it's unique than the congestion we experience in the big I internet. So there's much difference, delay bandwidth, different switches, architectures. The networks are much more homogeneous. There's a lot of high-speed links with compute and storage that's very in close proximity. And the traffic profiles are a little bit more predictable, a little bit more understood. And there's typically fewer people managing these things, maybe even one set of people. So the congestion management can be different in a data center. So, you know, where should we consider these things? If you look at the ICCRG, we could say, yep, their charter does mention data centers as a possible charter there. They're often quite full with their agenda. All the congestion work at standards track is certainly going on in TSV, WG. But perhaps maybe some of these topics are research oriented, so perhaps a new research group is worth it. So let's talk about it. We have some drafts to talk about. We have a side meeting that's coming up. So a couple of the key questions that we're trying to answer this time around. What are needed from NICs themselves to do better congestion control? There's a draft on an open congestion control framework where we can negotiate capabilities in a more open fashion and try to determine how the network and the NIC can work together. How can the network itself actually participate in congestion management in a different way or a more enhanced way? One thought is about configuring the parameters are very complicated. So can we use AI in a way to help model that? There's a draft on that. And then, of course, shortcutting the whole control loop could really reduce some of the delay in getting congestion and pressure on some of our buffers. So there's a fast feedback draft as well. There's some other interesting topics like maybe should we be measuring things differently in the data center as well. So we have a couple of drafts to review, discuss. Join us. We have a non-working group mailing list, RDMA-CC. You can subscribe to that. And we have a side meeting on Tuesday morning in VIP-A. So look forward to following on with these discussions.
Okay, thank you, Paul. Our next speaker, Nicholas Hart. Ooh, Nicholas, I'm noticing you have 16 slides and 4 minutes. So good luck.
That will be the world record. 16 slides in 4 minutes. Which button is the forward button?
It's the right arrow.
That's it, yeah.
There you go.
Okay.
Go for it.
I'll go real quick. I won't. They're very lightweight. I'm an academic.
Get closer to the microphone. They can't hear you.
Can you hear me? You hear me
Now
now?
I can
It's near field. Start the clock again. My name's Nick Hart. I'm from England, from Lancaster. I'm a university. I'm an academic. I'm a researcher. I'm actually a PhD student. Anyway, I'm going to talk about that later if people will approach me. I'm just going to give you some ancient history, the academic view of my topic, which is something that got called RCP, route control processing. What I'm interested in doing is automating BGP, programmable internet routing is what I'm calling it. In the academic world, we see that nothing really has changed for maybe a decade. I feel confident that's not the case, and the reason I'm here tonight is to invite people to come up and tell me what it is that we on the academic side don't get. So this is what we see. So in 2004, someone came up with a bright idea that you could invent a God box that would take control of an entire transit network. You'd flip all of the BGP connections, all the internal IBGP mesh onto this box, and of course, if the box went down, your network went down. This was the kind of academic idea of how to make networks better. Needless to say, this didn't fly. This next slide's from the same paper, and I'm putting that up because I'm going to come back later on and add my overlay to it to make it show how I can hopefully make a network change to where we want it to be without it having to take it apart first. From the same paper, their idea was two-stage. Firstly, they'd stick the God box in the middle, but the God box wouldn't talk to the external peers. It just talked to the internal ones, but still breaks the mesh. Their second idea, which is really the first slide, is that they basically take control of everything. IRSCP, same idea, a bit better. They've got root reflectors in there. This one's interesting because it's non-intrusive, but in fact, that doesn't do much more than just optimize IGP paths, which is pretty much what you can do without that solution. When they want to do anything brilliant, then they take over and you'll see the big black lines are just physical links there, data paths, not control links. So that's the world that the academics still live in. There's been no real change in that. There's another slide here. All these people doing this, people like Jennifer Rexford from Princeton and a whole bunch of people from AT&T wrote this stuff 12, 14 years ago. So my take on this is that cannot be the end of it. Why did this not go anywhere? And so I kind of try to encapsulate why that didn't work. And I think the problem was going back in those days, you couldn't get enough external routing state without breaking into the eBGP feeds. So the first question is, how can you do that? And I think we can solve that today. It's no secret how we're going to do that. And then the second question, which they didn't really address, is if they knew that they could do something better, how would they actually push that into the network without, again, breaking the mesh? So those are the two sides of it. The third piece is, how do you know what it is you want to do? But for me, that's a different problem. So here's the strategy. And this is so simple. I kind of feel like people must be doing this, but on the academic side, we don't see it. So to get the external routing state, you can either look at BMP. The problem with BMP is some implementations seem not to be reliable, but AdPath seems pretty much up to the task, and most of the routers out there, the border routers, can do that today. And the second solution, and I've already heard tonight, people say, yeah, we do that, but we don't know this on the academic side, is just pick the second best route and push it out there with higher preference. Not difficult. I thought about trying to extend BGP, but that's not a bright idea, not unless you're a member of the IETF. So here's my diagram. So that was the one I put up at the beginning. There's the mesh. My blue path is me pulling into my God box all of the additional path information. And the second piece is pushing it back out again by just sending routes with high local preference. All of this sounds really simple, and I'm looking forward to people telling me that actually I'm just behind the times, or I'm crazy and it doesn't work for the following reason. But any of that input would be truly welcome. So I'm new to the IETF. I don't have interact with you. Thank you.
Nick, since this is your first IETF meeting, take one moment and tell people how they should, if they want to collaborate with you, how should they reach you?
My accent is unique, so you'll spot me on the dance floor. My email address is there. I'd love to suggest a bar meeting, but I don't know where to go.
Okay.
So
maybe somebody will take you to a bar.
I'll be in the routing group meeting, work meeting. So hopefully, if there's anyone out there can tell me more, then they will. Thank you very much.
Thank you. Our next speaker is Mauro. I'm not even going to try your last name, Mauro, because I'm going to butcher it. So I apologize in advance. Okay. Need the microphone.
Okay, my name is Mauro Cociglio and come from Italy, Telecom Italia. Explicit in-band measurement is the topic of this short speech. The first case of explicit measurement is the spin bit. Spin bit is a RTT measurement. It is implemented on QUIC protocol. The spin bit idea is to create a square wave signal on the data flow using a bit, whose length is equal to RTT. An observer in the middle, wherever is located, can measure the end-to-end RTT only measuring the length on the square wave. The new idea that we propose is the round-trip packet loss, measured on production traffic between client and server. How it works. The client makes a train of production packets using the packet loss bit And these market packets bounces between client and server to complete 2 rounds between client and server. Client and server reflects market packets by marking production packets flowing in the opposite direction. And server counts the market packets during the 2 rounds and comparing the numbers can measure the losses. The main problem is the different speed between the 2 directions, upload and download. So we use a token system to have the same speed of market packets in the 2 directions. Okay, how it works. The client generates a train of market packets using the packet loss bit. The server reflects these packets. The client reflects the market packets again, and the server again reflects. So we complete 2 rounds between client and server. Not all the packets are marked, as you can see. This is the opposite case when the speed is different, is more in one direction towards the other direction. Okay. The observer is put in the middle. He can only count the packets. The packets of the first train is compared to the packets of the second train. So the packet loss is statistically measured. Statistically because is the round trip is between the server and not between the client and the server, but statistically is the main things, the same things. How to know more? We have a hackathon project, quick measurement and spin dump in cooperation with Ericsson. The draft was will be presented in TSWG meeting Thursday. And tomorrow we will be present in the hack demo happy hour with the spin dump demo. The mailing list is possible to use the TSWG mailing list or direct mail to us, Mauro Cociglio, Fabio Bulgarella, Giuseppe Fioccola, and Riccardo Sisto.
Thank you, Mauro. Our next speaker, Dirk Kuster.
Okay. So this talk connects to Tommy's first talk in the beginning. So in the IETF, IRTF, we have gotten used to using the term considerations for something, well, that is actually, well, we haven't really thought enough about in the beginning, but actually that turned out to be very important. For example, like security, human rights, perhaps. And so this is another topic that I think it's very important. So, well, the tussle between confidentiality, control points, and a bit the issue of consolidation and centralization. So after the, well, in the post-Snowden area, our response to the revelation was, okay, we have to rethink our stance on encryption and privacy, and basically made a decision, okay, that we want to ramp up our encryption work. So we knew before it's going to be important, but so we improved TLS. We are doing things like Quick, for example. So and also defend this against a lot of criticism. So very important work. On the other hand, we know that there are other problems that are big concerns. So so surveillance-based economies, platforms that track users all across the web. And so at some point, it's even the case that the technology that we are producing to, for example, protect the users against on-pass attacks, well, it can actually be used against the users in some circumstances. So for example, well, we can protect the, say, connection, the channel from on-pass surveillance, but it doesn't keep platforms, of course, from collecting profile data, trading this, and even trading this with say, institutions that are actually on the path. So we all are aware of that, and so we have started to react to this. So we are rethinking or enlarging the threat model. We are kind of trying to establish some principles, so what it means to develop technology for the user. We are rethinking, is there something wrong with our technology perhaps? And so I want to invite you to say a bit broader discussion on this topic. So to look at the bigger picture. So some of these problems, they're not caused by internet technologies per se. So that you have to understand, say, how the web works, how the economy works in that space. So we talk a lot about, consolidation, centralization recently. Of course, some particular topics that create quite some sensation. But I think it's really important that we try to take a step back and try to see the bigger picture. So what role are we playing? So what role is our technology stack playing in the bigger system? So consider technical and economic factors. So one topic here, for example, is control points in the network. So of course we don't like censorship. On the other hand, we need some control points. So right now, some of our technologies are used in a, say, sub-ideal way. So DNS, for example, is used a lot to implement control. So there's something that we can probably improve there. Also, when we say for the user, so what does it actually mean? So from an application, say, provider or developer perspective, we say, actually, we cannot trust the infrastructure, the underlying network, the underlying operating system. On the other hand, we could ask, can the user trust the application? What is the rule of OSs? So, if you're interested, talk to me more. Thank you.
Does anybody see an unattended laptop nearby? There appears to be one missing. Nick seems to have misplaced his laptop. Sorry, Nick. It's probably around here somewhere. Everybody else has one. Our next speaker is Jake Holland. Jake? Jake? Really? Oh, laptop found. Excellent. But speaker not. Okay, moving right along. Maybe we'll come back to Jake. Next speaker, David Oliver.
So I guess I'm dead last here. So these are lightning talks, but I'm going to TLDR the TLDR for you since I'm at the very end. We've been working in an area called pluggable transports where we're trying to provide solutions for people who are subject to pervasive monitoring and surveillance and censorship. And we've been working on this for quite a while and 4, 5, 6 years now. And so we're interested in what's coming and what's going, how active the sensors are and how active our community is. And we're looking at a couple new issues that arise now that much work has been done and things are constantly changing. So at this IETF, we've been doing work on usability related issues, that how users see these technologies come out and how they try to integrate them in the work that they do. And then we're also looking here to the future a little bit on how the devices that we use can help in making these technologies, these transport technologies, these circumvention technologies more usable and more efficient. So here's a brief update on the status of some of the pluggable transports that have been developed and used over the last number of years. Some of these have, some not mentioned here, have sort of fallen by the wayside. These are the ones that are still active that provide different sorts of technologies to evade censorship. One of the biggest problems that we now have with so many technologies in the field is reaching a network peer that understands the kind of communication you're trying to do. And so how users understand how to interact with bridges, with these communications bridges, is a big problem, and we're working on user experience solutions for that. How you select and find the right bridge and rendezvous with it. And then lastly, which form of pluggable transport do you need for the kind of surveillance regime you're in. This machine learning stuff is really brand new. It stems out of some work that's being done by a larger group who monitor how these technologies are used in the field. We're sort of mobile device experts, so we're interested in how mobile devices can help us in this effort, but also do so in a privacy preserving way. We're involved in a little hackathon thing today, working on setting up an environment to start doing more research in the user experience with these things. We'll be at the hackathon happy hour, hack demo happy hour here tomorrow night. You can come over and see us. Our work is encapsulated on a nice website called pluggabletransports.info, and we do have an internet draft out there that starts to talk about this stuff. Anyway, hit me up if you'd like to get involved with this sort of thing. Be happy to have people help us out. I'll be here all week. Thanks very much. I guess that's it.
Thank you, David. You can leave that there. We've got another talk, Shigeru Suzuki.
Hi, this is I'm Shigeru Suzuki from Keio University and WIDE, and also on the BSafe network, who is running some sort of a test bed for the blockchain technology. And I'd like to briefly update the discussion on the decentralized finance technology. Next, please.
Clicker's behind you, Shigeru.
Quickly.
Okay. And could you try to speak slowly, please?
Yes. So to the you deploy the decentralized finance technology, who need to be involved to create a healthy ecosystem for decentralized finance or like is really a question. And there are many people need to be involved to discuss how it is implemented. And interesting thing was happened. This slide that I was shown in the last IETF side meeting, I have allowed to have alongside with DIN research group. And interesting is that on the G20, it is strange to discuss about this in the IETF, but at the G20 meeting, the regulators agreed that just applying regulate things do not work. They realize that, and that they need to communicate with other stakeholders, including tech community, to how to implement the decentralized technology. That is a really interesting thing, I think. So their focus is, of course, the consumer protection and the prevention of the use of the technology for the criminal activity or whatever. So we need to respond to these activities. So last 4 months since the last IETF, we had learned several workshops, including a DFA workshop at the Scaling Bitcoin conference in Tel Aviv, and also I and my colleague attended several panel discussions to describe what's going on and what we want to do, and calling for the colleagues to work with. So we are planning to have some open meeting in March 2020 on March 9th to 10th in Japan, Tokyo, Japan. So I'm going to provide an update to the people who want to be involved. So, and we are going to have a mailing list. I promised in the last IETF meeting, and we are going to have it, and I'm going to let you know. And please find me and drop me an email if you have an interest on this activity. Thank you very much.
Thank you, Shigeru. Okay, one more call for Jake Holland. Looks like he didn't make the meeting. So that was our last talk. Thanks, everybody. I hope that you'll consider doing a lightning talk at the next IETF. Also, I'm doing an informal social event on Thursday night. Pecha Kucha and other sort of humorous lightning talks, feel free to join. The information is going out on the 106 attendees list, and I hope everybody can come. Thank you. Good night. Enjoy your dinner. Is anybody missing a marble? We have a found marble. Have you lost your marble?